So we are looking at matrices, and that's the plural form for the word matrix. So all a matrix is a rectangular array of numbers. An m by n matrix has m rows and n columns. This is known as the dimensions of the matrix. Find the dimensions of the following. Now, rows and columns may be a little different from what you're thinking. Rows always must go in the horizontal direction. So in this case, I would have 1 row, 2 rows, and 3 rows. And we always have to write the number of rows first. So I would say this has 3 rows by, and columns go this way. They always go in this vertical direction. So how many columns do we have? 2 columns. 1, 2. So 3 rows and 2 columns. All right, so let's look at this one. We want the dimensions, so we have to look at how many rows we have, and then how many columns we have. So Taylor, what do you think the dimensions would be for this one?
2 by 5.
2 by 5. And then, what do we use matrices for? Well, a matrix is basically the same thing as what you would have if you were to use a spreadsheet and you were to put numbers in that spreadsheet. It's just keeping track of data. So like this may represent store A and store B and their sales on Monday, Tuesday, Wednesday, Thursday, Friday. So if we owned more than 2 stores, we could keep it going for store C, D, E, F, G, etc. And you can see how that could help us to keep track of our data. So that's all we do with matrices, is kind of keep track of data. There would be some times where it's helpful to be able to add matrices. Sometimes we subtract, sometimes we multiply by a scalar, etc., which we'll talk about. All right, go ahead and write the dimensions of these two on your own. Katie, what did you put for C?
2 by 3.
2 by 3 is correct. And what did we put for letter D? What did you put on that, Tim, for letter D?
0 by 1.
No, we actually have 4 rows. See how this would be 1 row, 2 rows, 3 rows, 4 rows. So it's 4 by 1. All right, so look at what it says down here. To add and subtract matrices, the matrices must have the same dimensions. So we cannot add or subtract unless they're the same size of matrix. And that makes sense because think if I'm trying to add these two. I'd add up those 2 spots, but now I don't have anything to add to these. So they must be the same size. So if I'm going to add matrix A and B, I just add the corresponding parts. So like this is in the first row, first column. First row, first column. So I just add those 2 spots. 4 plus -6 is -2. And my next spot, this is in the first row, second column. So I just add up those spots. And so that's going to be -6. Same thing here. Add these 2 together. 2y plus 1y is 3y. So I'm talking about with the variables. And then I add up these 2. If I add those, is that 3x? Just 3 plus x. Good. All right, so now we're going to go ahead and subtract. And we just have to be careful with that we do actually subtract. So if I have 4 minus -6, that's 10. -1 minus -5. Well, that's going to be -1 plus 5, which is going to be 4. 2y minus y. That's 1y. 3 minus x is just 3 minus x. All right, so what do you guys think for B plus C? Can't do it. So when you can't do it, you can just write CBD, can't be done. And you guys go ahead now and do D minus C. So you have to start with D and subtract C. Alexis, can you read me what you got?
5x negative 7 negative 6 0 negative 3y.
Do we agree? All right, very good. Let's go over to the next page. All right, scalar multiplication. Scalar multiplication is very easy. This is just saying that everything inside the matrix is going to get multiplied by the scalar of negative 5. So we literally just multiply every number in there by negative 5, and we would have negative 10, positive 5, negative 15, and negative 20. No problem. Now, when we're multiplying two matrices, that is something different completely. This is pretty complicated, so watch closely. To multiply matrices, the columns of the first matrix must match the rows of the second matrix. Now, let me show you how you can quickly know whether they can be multiplied. They do not have to be the same size, okay? But here's what has to happen. The dimensions of this, it has 2 rows and it has 2 columns. This one has 2 rows and it has 1 column. So the number of columns here must match the number of rows here. And see how it does? Columns here matches rows here. So I just get rid of those now. This is going to tell me the size of my resulting matrix. My new matrix is going to have to be a 2 by 1. So I'm going to have 2 rows, 1 column. Now, I look at this spot. This right here is in the first row, first column. So that's what I'm going to use. I'm going to use the first row and the first column. Watch how I do this. I have to do 1 times 5 plus 2 times 6. That's what's going to go in that spot. So 1 times 5 is 5, plus 12 is going to give me 17. To figure out this one is in the second row, first column. So I must use the second row and the first column. And I have to match them up. So I'm going to have to do 3 times 5 plus 4 times 6. 3 times 5 is 15 plus 24. 15 plus 24 is going to give me 39. And so that's what we should get when we multiply those two matrices. I want to show you how you could do that on your calculator now. So get out your calculator. When you look at your calculator, right here is the word matrix. That's where we have to go to put in our matrix. Notice it's in blue, so I'm going to have to do second to get to it. I'm going to want to edit my matrix A. So I go over to Edit, and I click on A. This is my matrix A. This is a 2 by 2 matrix. The entries are 1, 2, 3, 4. Once you have it put in, you don't want to hit clear. You want to hit quit. So to quit, you're going to have to do second mode to quit. Now I have to put in matrix B. So I'm going to go back to matrix. I'm going to go over to edit because I want to edit matrix B. What are the dimensions again of matrix B? 2 by 1 is the dimensions. The entries are 5 and 6. Can I just hit clear? No, I have to quit. So now what I want to do is I want to multiply these two. So I have to go back to matrix and I have to just choose matrix A. I don't want to edit it this time. I just want to choose it. So I'm doing matrix A times, and now I go back to matrix B. And I'm saying to multiply those two matrices, and it tells me the answer should be 17 and 39. Okay? So it's nice to be able to check our work with this. All right, let's look at the second one now. Tell me the size of this second one right here. Danielle, what's the size of the first one?
2 by 3.
And Morgan, what's the size of the second one?
3 by 3.
And so these two match. Okay, so I know I can do it, and it's a 2 by 3 is going to be the result. So I'm going to have 2 rows, and I'm going to have 3 columns. So 2 rows and 3 columns. All right, so let's find out what goes here first. This is in the first row, first column. So I'm going to have to use the first row and the first column. And I'm going to have to match it up. It's going to be 5 times 3, 15 plus 1 plus 10. So 16 and 10 is 26. All right, let's find this one. This is in the first row, second column. So I'm going to have to use the first row again, but now the second column. Match it up. 5 plus -2 plus 0. So that's going to be 3. Now, you don't have to keep going in this order. Let's say we want to jump and find this. Maybe on the quiz, I have everything filled in except for this one, and I ask you what this one would be. Look at its position. What is its position? Noah, what position is that in? Second row and what? Third column. So I would have to use the second row right here and the third column right there. Match it up. I have to do 4 plus 0 plus -3. And that gives me 1. All right? On your own right now, I want you to find out what would go in this spot. Ethan, what'd you get?
5.
I don't think so. This is in the second row and the second column. So you match it up. It's going to be 2 plus 0 plus 0. Did you accidentally do 3 on the last one? Okay, so it's 2. How many people got 2? All right, good. Okay, so now let's check what we have so far by putting this back into our calculator. So let's go to Matrix. We're going to go over to Edit. What's the size of this matrix again? So 2 by 3. Put it in. You can just go right over top of your old matrix. People always think you have to delete these matrices. You don't ever have to delete them. Just keep them in there. Make sure you put it in right. Now go back to Matrix, over to Edit. This one is going to put in Matrix B. You could also use Matrix C, D, E, whatever you want. The matrices go on for quite a while on here. I don't know how far. Put it in. And now just go back to matrix A times matrix B. And we can check. We've got 26, 3, and then we know the rest of them should be 12 and 21. Okay? Any questions? All right, let's look at letter C here. What's the size of this matrix, everybody? 2 by 3. What's the size of this one? 2 by 2. Good news. Why? Can't be done. Okay? I'm not going to mess around with it. I'm not going to put in my calculator. I'm not going to do it by hand. It cannot be done. All right, let's look at the last one. No calculator. But I don't want you to find the whole thing. I just want you to find the diagonal. What would be the values that would go in the diagonal after you multiply? Go ahead and try it. Any of you get them all right? 26, 90, and 56? All right, very good. Okay, we're going to stop there.